Okay. So, we are back, and we'll see here in just a second how well things are running as we are starting with a little bit new equipment. But we shall see. Alrighty. Part 2 in the paired sum section. So, before we get started here, before we start going through all of these various problems, we're going to spend about an hour on this before moving on to some other work. We're going to look at diatorization and stuff. But, so what we're going to do is we're just going to do these particular lead code problems. But before we get into that, let's go over the various sub-strategies for the two-pointer strategy. So from the last stream, quick things, we have 3 types. The first of which is inward traversal, which is the moving of the left and right pointers from the sides of a given data structure towards its middle. The unidirectional traversal, which is the traversal of a given data structure in one direction. And the stage traversal, which is a multi-step process that moves one pointer in a direction until it meets the case, and then the second pointer will either go from the original pointer, will be initialized at the original pointer, and then move into a different direction, depending on what cases we're looking for. So those are the 3 sub-strategies that are listed in the Byte Go. So we're going to go ahead and take a look at some of the problems that they have proposed, and then after which we'll also go over to LeetCode and see if we can find a few more. And with that, so I have set up my particular repo here in a way that I can also set up some test cases so that we can test it on our own without needing to leave our particular IDE. It's just my own personal preference. But when we hop over to LeetCode, we'll also do a little bit of just in their IDE to synthesize that interview strategies kind of value set. Skill set. Value set is the wrong word. Okay, so let's take a look. So the first one is pair sum sorted. Now what I like to do with these is, it's just giving, okay. It's just giving these. Okay, that is not exactly what we looked for. Good thing I have it up over here, so we'll go from this thing. All right, so 2 sums. I'm pretty sure I've solved this one. Yeah, I've solved this one before, but I haven't done it in Python, so it's okay. So 2 sum. So we'll go ahead and I'm going to just juke this. Put that over here. We're going to have a directory. We're going to call this 2 sum. We're going to create a new Jupyter things. Call it solution. We'll go ahead and we're going to paste this. Not a fan of that. Let's do it this way. Add a README. And I gotta make sure I'm in my text based. Here we go. Go ahead and post that. Okay. That is still not great. Let's see. There we go. Much better. Okay. And then what we're going to do is we're going to have a new Python file. We'll do 2 sum. We're actually going to do test. I'm sure 2 sum.py. We're going to set up our basic test suite here. Okay, move these away. also going to grab the test cases that they have. They're over here. So input is this, expected to 9, and let's see, and they're calling this, so we'll go here. Okay. We're gonna set up our expected case. No. Okay. And they're giving self, nums, and a target. And let's go back. Let's see. Target is 9. So, and we return 0 and 1. Okay, so they're expecting array. Target expected is equal to 0, 0, comma 1. And we're setting target to target and is equal to expected. Okay. Let's see. Inputs target equals strings. So if we go ahead and let's test the connections here, we're going to just return 0, comma 1. Let's see, why is my particular things? And this is the other reason why we're doing this, is so we're getting a little more familiar with, for myself at least, I'm getting a little bit more familiar with how modules and such work with Python. So this is also a bit of a learning experience for myself. Okay. Let's see. Alright, list is not defined. Okay, so first thing we need to do is figure out why we're failing on this. So let's do list typing parameters in Python. we have to actually import it from typing. Okay. There we go. Okay, and this is again the reason why I like doing things like that is if we take a look at this, you don't see any of that. So it's kind of like abstracted away from your viewpoint. So you might get used to something like this, and if you're just getting started out, like that can be a real trip up, especially when you start switching, which is the big reason why I like doing all of my like LeetCode problems within my own IDE. I mean, there's other reasons, of course, because you get auto intelligence sense and all that kind of stuff, which you typically won't have if you're just doing it through the platform. They like to test that you know, remember everything about the language that you work on, and the idea of like, oh yeah, you're going to be working in this environment. Yeah, you're going to be using Notepad with 0 extensions. Yeah, right. Yeah. So, but I understand their sentiment, but this is just how I work. It would be a little bit more realistic. So let's go ahead and try running this case again. Make sure that these things let's see, missing, oh, I need to pass in self. That's right. So let's see, and this is that in that beginning level of things requiring one. Well, actually, wait, this might actually be fine now. Yeah, that's fine now. Okay, yeah, it's because I have to instantiate our class, typical, and then actually call our thing. Okay, so I'm actually going to throw this up here, solving class, and then we'll actually go ahead and run this. All right, so as we can see, we now have a passing case. Cool. So now that we have our actual back and forth wired together, let's go ahead and grab some of these other test cases. All right, so we're just gonna this. Actually, you know what? Let's make this even better. Let's see. How do we do in PyTest parameterized cases? PyTest. Parameterized test cases. Let's see. Here we go. This is what I'm looking for. Different options for test IDs. All right, so A, B, expected. Okay, cool. So test data, and then we mark it with PyTest mark parameterized AB. Cool. All right, so let's go ahead and put this in here, not over there. All right, so we're gonna do input for nums. We're actually gonna, we'll go ahead and make it really easy to follow because that's my style. Target, and then expected, and then test data. So we need to create a structure of test data. Test data equal to, and I believe that they were using an array, which would make the most sense. Arrays and tuples, okay, or triples, whatever it is, whichever thing. So in this case, it's a triple. So I guess, do you still call tuples if they have 3 items tuples? Let's double check that. I wanna think. You still call a tuple. You still call it a tuple even if there are 3 or more elements. Yes, so sequence of 3 elements is a triple. Okay, so they do have specific names, but if you wanted to just say n tuple, okay, that's cool. That's fine. All right, so we're gonna be making triples. That works. Alrighty, so our first one, we're gonna do this. And our target is gonna be 9, and our expected is 0, 1. Okay, so the big thing is here is that I want to get like just a general case for how to use these things, and then in the future we'll just be allowing we'll do some we'll be actually using AI to help us generate some of these test cases. We're gonna look for edge cases and stuff ourselves, but for some of the basic test cases, we'll let AI do the work for us here, since I could spend all day writing out these things myself, which may help learning and getting more familiar with the syntax, but it's not really the best use of my time, and that is from how are they doing the imports again? They're just doing a straight import of PyTest. Okay. Let's do a test to make sure this is working. Indirect fixture E does not exist. Still need to run. I needed a. Let's see, 6 parameters set specified with different number of IDs. So I'm clearly missing the syntax here. Okay, I need to actually specify. Interesting. Why is this one needing? Okay, I am starting to see. I needed to do. Got the syntax incorrect here. Test data, and it had another thing there that was doing that, but that seems to pass. I just want to read this real quick. Let's see. IDs forward and backward. I don't quite understand why they're doing that. What's doc say? Okay, so they're labeling it. Okay, so this is V1. So in test time distance V1, we specified IDs as a list of strings which were used as the test IDs. These are succinct but can be pain to maintain. Okay, so this is... okay, so it's just giving the multiple test an actual name association with it. Okay, cool. As a function that can generate a string representation to make parts of things. So in here, ID functions. Okay, so this is just a way to abstract the way of how you name the tests. Okay, that's fine. I'm not going to worry about that for right now. I just want the basic test solution. Okay, so I think we can also extract this out. Yeah, let's double check to make that sure that's working. Awesome, fantastic. All right, so let's set up our other test data. So back to LeetCode, 2 sums. All right, so 3, 2, and 4, and our target is 6. 6, and this would be 1, comma 2, because 2 and 4 add up to 6. And then our third test case, 3 and 3, target is 6. Okay, 3 and 3, target is 6. And this would be O, comma 1. But, okay, so let's read this thing. So, given an array of integers, nums, and integers, return indices of 2 numbers such that they add up to the target. You may assume that each input would have exactly one solution, and you may not use, and there's the key edge case, you may not use the same element twice. You can return the answer in any order. Okay, cool. That's good to know. So we'll have to change some of our test cases here. Not use the same element twice, but if the element exists twice, so it's not like 3 and 3 are completely eliminated. It's just okay. So minus this, and we'll go ahead and take a look at this. So these are our test cases on the far right. On the left is our actually, you know what? Let's set this up exactly like it. All right, I like this. Summary, things, solution, test cases. Okay, nice. So, first thing we need to identify is, so we have our examples, we have our constraints. So 2 to 104. Nums can be any, so the length of the array can be anywhere between 2 and 104 elements, and the numbers can be anywhere between negative 109 and positive 109, and our target is also going to be somewhere in between those two numbers, and only 2 valid things can exist. Okay, so first one, so we can always assume that there's one valid answer, so that means we don't have to do like null cases of like empty array or there's no cases or something, so we don't need to worry about that. So we don't have to set up any test for that. We do need to set up a test for negative and positive numbers. So let's go ahead and do that. Let's do one that's a little bit larger. Let's do negative 10, do 2, 7, 8, and 2. And our target is going to be negative 8. So the expected outcome of this one will be 0 and the last pointer, which is 0, 1, 2, 3, 4. So 0 and 4. So go ahead and put that in there. So that covers our negative case. What else do we want to do? Any other edge cases? Negative and a negative. When you sum 2 negatives together, you get a bigger negative. So let's go ahead and add that together. So let's do negative 6, negative 4, and our test case here is negative 10, with it being 0, 1. So we handle 2 negatives, 2 positives. We don't have to worry about out of bounds. We don't have to worry about things. So I think we'll go ahead and leave this, and we're gonna go ahead and get the rest of these because these should do that. So let's go ahead and test to make sure that all of them are running, and I'm just gonna return a one that I know is incorrect. We're gonna go ahead and run this. Cool. So now you can see down here we have all of our test cases running with the parameters. It looks a lot cleaner, in my opinion, personally. But we'll go ahead and do this. So let's go ahead and solve for this. So based on our 2 or 3 strategies, which one would be the most effective for this solution? And the one that makes the most sense is unidirectional, because we want the 2 pointers. Would 2 be the best solution, or would... I mean, we could actually orchestrate all 3 strategies into this, but there's something about it that I don't want. So the follow-up is that we can do it in n squared time. So let's do, you know what, less than exponential. So what I'm going to do is I'm going to do one that's just brute forcing, and then the next one I'm going to see if we can get that optimization. So with this one, even if we're doing the 2-pointer strategy unidirectional, it's effectively just doing 2 for loops, because you're starting with one, you're iterating all the way through, it doesn't come back. So do a second one, which is just 2 for loops wrapped. So let me think. Okay, so the other thing that we need to take into account is that the 2-pointer strategy works best with a organized array, or you basically need one. So the first thing that we need to do to actually... Oh, excuse me. Oh, goodness. Excuse me. All right, continuing on. The first thing we need to do for all of these things is to actually organize our arrays, right? So what we're going to do is the first step to this is we're going to do nums.sort. So now we know that the numbers are going either from least to most, which is that way we can now generate a solution that is more poignant and allows us to leverage that organized array and understanding of it. So now that we have it sorted, let's see how we can set this up. So in this case, I'm wondering if the staged one makes the most sense. And hear me out on this. What we could do is, using the target, we can take the element that we're looking at and then determine if we need a larger element than it or a smaller element of it, and then send the second pointer either in each of the directions that it came from. We can do some other logic there to do some math. Okay, so let's start out with this. So what we're going to do is we're going to pseudocode this out so that we have an understanding, and also it's a good practice to understand how pseudocode works, so that when you're coming up with problems, before you start writing it in code, you understand the verbal exchange, the English version of it, basically, how you solve the problem. And then additionally, that pseudocode could be applied to any programming language, since the actual way that you're solving the problem isn't changing between the two. Okay, so let's go ahead and pseudocode this out. So the first thing, and we're going to go ahead and do this. So first thing is to utilize a two-pointer strategy. The array, or the data structure must follow an organized, must have a organized nature to it. Must have an organized nature to it. Therefore, we use nums.sort. So we'll insert this. Now, to solve this, oh, and I went back. You know what? First things first. Brute force. Then we'll come back to this. So we're gonna have two definitions. So definition brute self nums, and it's gonna be a list of integers and a target of int. And brute, we're just gonna, we could use the two-pointer. You know what? We'll do the two-pointer just to make this more clear why. So for this one, we'll go ahead and copy this up here. Okay, so brute, and then we have two-sum, which will be our optimization. You know what? Let's do, I'm gonna actually rename this. So, where's my F keys? Here we go. Or actually, no, that's not it. This is my F key. There we go. Solution. Let's call it two-sum. Yep. Okay. Oh, I also call it. That's fine. And we're going to call this test brute. And then we're going to copy all of this. I'm going to call this test actually, you know what? Let's actually do this slightly differently. Let's make this even more. So two-sum, we're going to call this unidirectional. Unidirectional. We're going to call this staged transaction, or traversal. So we're going to have unidirectional, staged traversal, and inward self nums list and okay. So what we'll do here is we're going to test each of these strategies so we can get comfortable with how they look like. also going to do this. Testing, test, staged. And this is unidirectional stage traversal. Nice. Okay, so now we have 3 methods. We're going to actually try and solve this with all 3 of the various strategies. This will allow us to kind of get a better idea of how they work, what their time complexities are in comparison with each other, and how to think about each of the problems. Because the thought process for each of the strategies is going to be slightly different. So, let's go ahead and do this. So, let's start with inward traversal because it makes the most sense to start with. The one thing I am seeing an issue with is how are we going to maneuver these in the direction that we want? I can see how it would work. Because if you go inward and you look at the 2 numbers, if they don't add up the target and you need to go left, if you need to add more, you go from the left. If you need to add less, you go from the right. You move the pointers in the directions. It would work. The only caveat with it is that if the number, we would need to actually shift right and left. And there, I could see us getting into a problem where we're hitting a case where we just keep on shifting left and right. But it makes the most sense. Let's also do a quick search of if the inward traversal only can occur inward or if it can go back and forth. Just so we understand. So let's do 2-pointer strategy. Can the pointers... let's do the pointers have to move only inward? And I totally spelled that wrong. It's fine. So the direction and speed of the pointers depend entirely on the specific problem you're trying to solve. Okay, that's good. Follows 2 pointers starting at opposite ends of the dragon and moving towards each other. But that doesn't necessarily say, okay, so let's see. Oh, yeah, nice. LeetCode gives us an example. All right. Oh my god, all the advertisements. Ugh. Okay, it's fine. I don't want to look at the answers. I just want to know. I don't want to look at the answers. Okay, you know what? That's fine. We'll go ahead and understand that we can do that. So let's go ahead and do this. So let's do hashtag initialize pointers at opposite ends of the data. Okay. Start, or let's say the case. So if the case is going to be the sum of 2 numbers equal the target, let's do setup case function to compare two inputs to the expected value. I don't necessarily like that though. Let's actually just do it. So we'll just go ahead and start our loop. So loop through elements of nums. So we'll have our case check at the top. So we'll say check to see if the two pointers are so it's not just as easy as just saying is it the case. What we have to do is we have to actually say we need to see if it needs to decrease or if it needs to increase. So we'll say get okay, so we'll get difference, the difference of the yes, possible Ben Vader. Yes. Best viewers in streamview.com. You know what I'm gonna do with you, my friend. Ooh, can I even do it from here? I don't believe I can, so I'll need to pull it up on the Le Twitch. Pull this down here real quick. Here we go. And where is my abilities? Oh, that's my stream preview. There we go. Perfect. Here we go. Nice. All right, and we've banned the user, which is perfectly fine. Okay, continuing on. So I will have none of that. Where was I? Regaining the particular flow. Okay, yeah, there we go. So, all right, we are working on inward traversal, initialize pointers at the opposite ends of the data structures, loop through each of the given elements in the numbers, and get the difference of the two value of the summed elements minus the target. That will give us things. So, and then we can add our if case. If the difference is 0, we know that we have found the particular answer that we're looking for. So then we can say, if the difference is 0, break, return indexes, or we'll say break, return elements. However, we found the particular answer that we're looking for. So the next thing that we'll have is we need to handle if it's either more or less. So let's think about this. So if it is less, we can move the right pointer to the left because that means that we're going smaller. We need less numbers. And we can move the pointer to the left pointer to the right if we need more. So what we'll do is if the difference is negative, is less than 0, move the left pointer right. If the difference is positive, or actually, you know what? I want to make this less code specific, and I want to focus more on the English. Is negative move move because that's what we're doing. Move the left pointer to the right if the difference is positive. Go ahead and we're going to say move the right pointer left. And then we'll continue. Now, one of the things that I am concerned about with this particular solution is that we're going to hit an infinite use case. So one of the things I do want to do is I want to say if count, and we're just doing this because once we get the correct answer, we don't need this. If counter, if the counter ever goes above the length, or if we've taken more actions than the length of the array, we also want to break. So if counter is, or add 1, actually we're just going to do add 1 to add to counter, or actually what's a good thing? Short circuit. Add to short circuit. And we're going to just quickly find out that I'm just illiterate. Ugh. CIRCUL. Okay, CIRCUL circuit. CUIT. Ugh. Okay, there we go. Add to short circuit condition. Things. We're gonna say initialize short circuit condition, short circuit value for 2n of list size, just so that we don't ever hit that infinite loop. Okay. Now, do I want to set up edge cases right now in terms of this? I do not. I think I'm just going to leave that as it is. We'll go ahead and implement this. So first things first, we're going to go ahead and just fill out our pseudocode. So we're going to say short circuit. So short is equal to 2 times len of the nums. Initialize our pointers. So left pointer is equal to 0, and right pointer is equal to len of nums. Believe that len does not, it gives us things. We'll need to do that to get the index. Okay. Loop thing. So while, and then we're gonna, this will be different for things, but while short circuit is greater than index, hold on, this condition is actually going to be 0 is less than 2 times len of nums. Continue. All right, so we're going to get the diff. So diff is equal to the sum of nums. Actually, I'm going to actually write this out. So we'll get left num is equal to left number element is equal to nums bracket left pointer right element equal to nums bracket right pointer, and then we're going to have our diff is equal to the left element plus right element minus the target. If difference is equivalent to 0, break. Else if the difference is less than 0, we want to move the left pointer is equal to left pointer plus 1. If difference is greater than 0, we want to do right pointer is equal to right pointer minus 1. And then additionally, we want our short circuit plus equals to short circuit plus 1. And this can go away at some point. I just want to make sure. So let's go ahead. Oh, and we need to, I should have included this in the pseudocode. Return left and right pointers. So return left pointer, right pointer. Okay. So we're traversing through each now, and we're going to see if this works. I see a better strategy could have been here for me to actually take a test case and make sure it works with each of the pseudocodes. I didn't quite do that. But I think it will be good. So we'll go ahead and run this, and we'll go ahead and follow that that best practice here a little later. So Cool. We have... So we passed the first one, but we failed the second one. So why did we fail the second one? Ha. And I should have seen this problem ahead of time. But so what is the problem for which we just ran into? The problem is that when we sorted it, so let's guide through this. So we returned the left and right pointers, and those are indexes. But if you remember, to perform this strategy, we organized the array into an ordered sort. And I believe here, yep, as you can see here, these are not ordered. So what does that mean? It means that we've changed the indexes. So we need to come up with a solution which allows us to sort the array but still work with the ordered solution, which means we need to find the original indexes. Now, there's a few different strategies you can do here. Either we can attempt to solve it using an unorganized way and look ahead, do like look-aheads to see like, okay, is the next number negative or positive, but then it's getting really complex. So a better thing that we're going to need to do is keep track of the original indexes. Now, how do we want to do that? So, golden rule is you never mutate the original input. But for this, we're going to go, because we'll have to add some space complexity to this. Okay. So what we're going to do is we're going to take this nums and we're going to make a copy of it. And now I'm not sure if Python gives us a nice copy function. So it's Python copy function. Yep. So okay, so yep, so this will work. We have 3 times. So we're going to import copy. We're going to make a copy. So copy or nums copy is equal to nums or copy dot copy nums. And then we're going to do nums underscore copy dot sort. Okay, so that's fine. Yeah, this only works in the fact that it's not positional, and the fact the question is saying that there's only ever going to be one solution. There's not going to be multiple different solutions, and you need to either come up with the first, the middle, or the last. So the only reason why we can actually do this is due to the fact that there's only one solution. So that's fine. So we copied our array. We're now going to use this as um, our iterator to get our values. Yeah, that's fine. We can still we're just gonna use it all the way through. Alrighty, and then what we're gonna do here is we're gonna get the original pointer. So get original indexes of elements. So we're gonna do left index is equal to nums dot I think there's a find of some sort. Index, I think, is what we want. Index of nums copy bracket left index or left pointer. And right index is equal to nums dot index of nums copy right pointer. And I'm already starting to see a problem here as well. The problem here is that if there are two elements of the exact same, which we actually have in our case, it's going to give me the index of either one or the other. So let us do a quick lookup of how the index function or the index method on a given Python list works. So Python list index of value. All right, so list index start and end. Oh, cool. So we can do that. So the first one we'll do just with this, and then we're going to do is start is going to be left index. So if there is a right index, but this isn't going to work either, because what happens if the number is coming to the left or it's already been there? So we're going to say if we're actually going to move these out. So what this is doing is it's saying, hey, if the left element is equal to the right element, then go ahead and initialize the search at the left index. Otherwise, just do right index equals to num else. Right index is equal to the same thing that we're doing. So nums dot index nums copy. Actually, you know what? We don't even need this. We can just do right element, left element, index, right index. Okay. So this should give us a bit more. Not a huge fan that it's gotten so complex, because seriously, I could have just used a for loop, just double for loop to get this, but if we're going for efficiency's sake, I think this is actually slightly more efficient than a double loop. We'll analyze its complexity here in a bit. So let's test this once more. Cool. Test inward traversal. So where did we go wrong with this particular thing? And this is where this is where running through your test cases makes the most sense, because I just realized that the way we set up our cases, and this is the things for the negative numbers, is not going to work nearly as well here. Which is fine. It's fine. And this is the understanding that comes from working with different ways of solving the same problem. Because you could easily solve it with the brute strength, but understanding the best way to do one or the other is an interesting proposition. So first off, let's go ahead and we'll start from this. So first off, this needs to be +1. So we want it to start 1 away from the left index. So this is going to fail in the next one. Yep, because our cases for this don't make any sense. Okay, so let's go ahead and look at the cases here. So our original problem is we were just looking at the difference, but it does not take into account what the actual original numbers were, which is our issue. So let's break this down. So where are we failing here? I'm assuming that we're failing because the difference is not in the way that we want it to be, but I don't think that's necessarily the case. I think that our test problem is the issue. The test problem being 0 and 4, but the first index of which is actually 0 and 1. So this is actually just an incorrect test case, because the answers would be 0 and 1, not 0 and 4. It's just because the 2 is repeated. So let's run this again. Okay, so now everything is passing. I think that is correct. I want to say I'm missing something, but let's go ahead and take this, because we've been working on this for a while. So let's go ahead and take this solution, and we're going to take this and we're going to throw it into the LEET code, and we're going to see what we get. So there's a lot of comments, so I'm going to strip out all of my comments here, just so we're making this a little bit more organized. And then, whoa, too much, too much. We'll go and see ahead and see what we got. Okay, so we know that all of our test cases are going to pass here. Oh, I need to indent. And this is why I'm not a fan of in the way that these things are indented. I need to take these things and unindent them once. Lovely. Or twice, actually. There we go. Now all of our indenting is correct, I believe. Let's run it. Yep, it's correct. Sweet. Okay, so we have our 3 test cases. Let's try this out. I think we're going to fail on something, but we'll see. Cool. All right, we did not. Which is awesome. So that means that we created the correct solution of using 2 points. Now, let's analyze this. So let's see what this is saying. What's the analyze complexity here? Server is busy. That's fine. So let us analyze this. So how do I explain analyzing time complexity? So time complexity is how long it takes. So let's go through. Because is this going to be something where I need to explain the lectures of O of n and O of n squared? Let's do just O of n. Because worst case is that it's n, just doing multiple iterations of the same length. It's not exponential at all. So I know that it's linear time because we're going through it. We're just going through it multiple times because this is an O of n. Or the sort is a linear function. Thanks. I mean, it depends on what sort algorithm you're using. Python sort time complexity. So what is n's things? So it's doing O of n because it under the hood is using which sort algorithm does Python use under the hood? Tim sort, of course. Yeah, that makes sense. Oh, they changed it in 3.11 to power sort. Interesting. I don't think I've heard of Tim sort. I don't think I've ever heard of power sort. That's fine. Okay, whatever. Power sort is a stable merge sort, okay, variant that adapts existing runs in the input data, i.e., ranges in the input that are already in order. Made stack of runs yet to be merged and alternates between finding the next run and merging adjacent runs near the top of the run stack. This non-recursive mode of operation is particularly cache friendly. Like Tim sort, it enforces the minimal run length by filling up short runs using insertion sort up to a chosen minimal run length and merge things. Cool. Okay, so that will be a different video. We'll go into sortings later. But this then runs in n log n, or logarithmic, is I believe what it's called. Let's double check myself so I'm not making up things. Oh, and we're doing, yeah, we're doing worst case. Yeah. Okay, so worst case, because that's what we want to do. So linear rhythmic time. Okay, so this would be n. I think that I need to do some research for myself on how to count worst case scenarios, because I've done a bit of it, but realistically, we're only going through this. It's not necessarily a singular loop. It's not like we're going. Oh, it is actually a singular loop because we're going back and forth, which is given a. We go through each element looping once, so it is n. Worst case scenario, it is n, because we'll do one on the left, one on the right, one on the left, one on the right, one on the left, one on the right. So worst case scenario, it is linear. So let's do this. So / worst time complexity is O of n, because we have to go through it, all elements, at least once. So let's see if we can run this again. Let's see if my that's fine. We'll use the chat GPT, or not the chat GPT. We'll use chat GPT to give us an estimate here. So in to sum inward reversal, what is the worst case time complexity? We're going to go with 4-0. Actually, you know what we'll do? We'll go ahead and ask the 5th because I want an explanation. A good one. Okay, worst time complexity is n log n. The sorting the copy of the list denominates at ON. The 2-point loops run in ON, and the final index lookups are ON into overall is n log n plus n, which simplifies to just ON log of n. So this sort at the top is what is killing us. Nice. But I'm wondering if it... Yeah. So that sort is what turns this into n log of n, which is annoying. Let's see. Yeah, and then you have things. It's just fine. Okay, so that is how we did it with a inward sort. But how would we do it with a unidirectional sort, which is, I know for a fact, going to be 2O of n squared. So let's go ahead and do the second one. So unidirectional. So one directional, 2-pointer strategy. Okay, so before we get started with that, we're going to go ahead and take a break. So I'm going to pause the stream and mute myself, and we're going to take a bit of a break so I can drink water and do all of this fun stuff before going through unidirectional strategy for 2-sum, which is just going to be a double for loop, but hey, we're still going to do it. Okay, so I will see you back here in 5-ish minutes. And yeah, still good. So I'm going to go ahead and mute myself, and I'll see you in a second. turn on the volume. Okay, now we are back. Here we go. Big money. Alrighty. So, now that we've accomplished this with our inward directions, we want to do a unidirectional sort. So, what does this mean? This one is pretty straightforward. It is going to be, we have 2 pointers. They're going to start from the same place, and we're going to go until we find one that fits. Now, the benefit of this particular solution is that we don't necessarily need to sort the array. It would make it better, but doesn't necessarily mean. So we could do some improvements on it, but I think for this one we're just actually not going to sort it because we're going to iterate over each one. Now, that being said, do we want to do that? It would make the solution a bit more effective if we do the sort, but we still could end up with worst case time complexity. So let's leave off the sort and just start from 0 and go in the directions. Okay, so go ahead and do that. So here we go. We are doing unidirectional. We're not going to use stage directional just yet. So what we're going to say here is this. First thing we're going to do is we're going to initialize left, right pointers. We're going to loop through nums and loop through. We're going to say we're going to have our things of find obtain difference between we don't need to do this. We don't even need to do that. We just need it to come out. So is the elements do the left and right elements equal break return indexes break else if they are equal break else if the right pointer plus 1 does not is still within limits increase, otherwise actually we need to do a second loop here, and we could do it all if it would just makes more do it. Loop through nums using second pointer. Actually cut this. So loop through the nums with the first pointer. If is left element and right element are the two elements equal to the difference or to the target, I really just want it to just be in that second one. We're gonna have to add extra logic and stuff, but we could just have a flag. Just want it to be in one loop though. Okay. So I want simplicity. Simplicity. All right, so loop through the numbers with the because we don't want it both. Loop through nums. Jeez. If elements, let's see, break if elements sum to target, otherwise move right index or right pointer right if right pointer is greater than or is equal to num's length. Set length, set left pointer length, set the left pointer right and right pointer to left. Return left and right pointer. So now we have our 2 pointers as they go through. When the right pointer, if we find the target, we break out. If the right pointer, and then we just move the right pointer along. If the right pointer reaches a point where it is greater or is equal to the length of the nums, we move the left pointer over one, we reset the right pointer, and we continue doing that, allowing us to get that more seamless flow without writing 2 while loops. Okay, so let's go ahead and implement this. So left pointer is equal to 0, right pointer is equal to 0, while true. Why is it screaming with me? Seriously? Whatever. While true is if nums left pointer plus nums right pointer is equal to target break else if or no if no, so right pointer is equal to right pointer plus 1 if right pointer is equal to len of nums left pointer plus equal 1, or gosh, you can't do that, pointer plus 1, and right pointer is equal to left pointer, and then we continue. Let's move these around. Okay, so let's go ahead and run this. Oh, that's right, because can't use the same element, so we need to make sure that our right index is always one more than our left index. Okay. This is why you always have your test cases. Yep, there you go. All 5 are test passing, so we'll go ahead and copy this. We're going to go ahead and do a new submission. And we're going to see this, and this is going to definitely be slower because this is a double for loop. Effectively, it is a double for loop, which is going to be exponential. Now you clearly could do some improvements here with like sorting and stuff and try to make it things, but in the whatever you do, it's always going to be worst case scenario is always and will always be n squared. You know, you could start somewhere in the middle and do effective things, but that's not necessarily the best case either. Okay, so let's go ahead and run this. So all of our test cases will pass here. Great. And we're going to go ahead and submit this. And what we're going to see is that it's going to be quite bad. Yeah, as you can see, it's way out there. And the reason why is because of the fact that you are effectively doing a 2n solution, or n squared solution, and at that exponential. So, with that in mind, but this is unidirectional. We are going in one direction. Now, we could improve this by saying, okay, hey, take a look at the target, take a look at the first and last number, and then doing some improvements that way, but then you're starting to add in a lot of improvements where maybe it just doesn't fit. But that's one thing. So we've now done this with the unidirectional. Let's do it with the stage directional. Stage traversal, not directional. My bad. Okay, so the same problem exists as we did with problem 1, which is the fact that we need to know where or what order the array has. So we do need, in fact, a organized array, which is why we're using nums.sort for this. Because now we have an idea of where to start. Now, this is where things can get a little bit interesting. So what we're going to do is we can either start left or right. And honestly, this still is probably 2 of n complexity, because you move it left or right, not necessarily. You could have done the same thing with the inward, the unidirectional as well. Let me think. So, for this particular one, if we go, we can either start on the left or the right solution and then choose to go in the direction in which we prefer. The problem with that is that then we have to do a lot of logic changes depending on which direction we start from. And honestly, it's about the same complexity. No, it's not. If we order it, it's double complexity. Because we just effectively, if we ordered the solution, we'd be effectively repeating unidirectional. Why is that? Because we know exactly, like, hey, we need to either add up. We're going to eventually just be going up through it. No. Wait. Go back. If we do order it first, we know exactly, hey, we need to either add numbers or less numbers than this. Okay, you know what? I'm thinking about this too much in my own head, so let's verbalize this. Let's go through this together. Okay, so let's start with an organization, because then we know what direction we need to go. Cool. So let us initialize our pointers. These pointers. So, and then similarly with inward traversal, we need to copy our original thing. So if we're going to mutate it, we need to understand how we mutated it. So, make a copy of the original nums array. Initialize right and left pointers. Initialize left and right elements. We're going to have our loop through, or we're going to have our loop here. We're going to have our output. So we're going to need get indexes of original for elements. If left and right elements are the same, start index, otherwise get index of, and we can do, these are implementation for elements, return return original indexes elements. Okay. And this is where things are going to get interesting. So we're going to loop through. And then we're going to decide on a direction. So, like inward traversal, we're going to do obtain difference of summed elements and target. Because this is like this is literally a combination. We're using similar strategies in the inward and the unidirectional. So obtain the differences of the summed elements and the target. Then, based on that difference, we're going to send that second pointer either left or right, depending on it. So if we're sending the pointer left, it means that the difference is less. Now that's not quite right. We don't actually want the summed element, so this isn't quite right. So it's obtain the difference of the left element, or it's actually obtain the difference of target minus left element. Now, this is going to get a little weird, especially with negatives. So we're going to obtain the difference of the target and the left element, but if it is a negative, that's going to result in a positive number. So we're going to do the math, the absolute value of the left element. Does that work? So target minus, so say we have 7 minus negative 2. Seven minus negative 2. The absolute value of which would be 5. And this is where that part of understanding the context of where you are sending the information into that case is very important, because that won't work. Because the initial value is negative 2, so it is 9 that we're looking for. So that's actually, it is just the left element would be negative. We would want 9. So target, which is 7, minus negative 2 would result in 9. When we add those two together, negative 2 and 9, we would get 7. Therefore, that is. So obtain the difference of the target minus the left element. That is actually correct. So we don't need to add any absolutions. We're just good. So we've obtained the difference of the things. Based on the difference, we now know what direction to go from the left element. So if the difference is greater than left element, we need to send the right pointer right. If the difference is lesser than left element, send the right pointer left. Now let's double check my understanding of this. What happens if, say, it's 7 and negative 10, you get 17, which would still be 17 plus, so 7 and negative 10 would be 17 would be the value you would get. So you need 17 plus negative 10 would still equal out to 7. Okay, yep. So send the pointer, the right pointer left. And then inside of each of these, we need a case. And that case is if it is equal, so we need to do our case. So if the right element and then our while loop actually is going to be while the right pointer is less than size of the length of numbers continue to iterate while the right pointer is less than the length of numbers. Continue to send that right pointer right. If at any point in time the case is if element is equal to difference, break. If the element is greater than difference, break. Else move the right pointer right. And I guess the problem is that we're saying left and right pointers, but at some point the right pointer will become the left pointer. So we're going to just call this second pointer and first and second pointers. And we're going to say first and second elements instead to make this a little bit more clearer. Okay, else move the second pointer right. which is good. All right, so if the difference is greater, if the difference is lesser than the left element, if the difference is lesser than the second, no, the first element, this is correct. If the, so if the difference is less, send the second pointer left. And then this is going to be, oops. So this is going to be while the second pointer is greater than 0. Case if the second element is equal to difference break, which is our case here. This is our break case, our second break case. So case if the second element is less than the difference break, and then else move the second pointer left. That's fine. Okay. We're gonna think. I'm still trying to think through the time complexity here because I feel like it's still 2 of n, but or not 2 of n squared. I'm pretty sure this is still n squared. But yes. No, it's not because we're doing the difference. I even thought about this before. Okay, so, and then case. If first and second, actually no, we still need to do this. If second and first, or first and second element are equal break, are equal to target break, and then get indexes for original elements. Okay. Okay, let's go ahead and let's code this out. So nums dot copy nums, just go, let's see. Okay, a copy of nums is equal to a copy nums copy nums. And this is just shallow copies. Initialize first and second pointers. So left first pointer is equal to 0. Second pointer is equal to 0. First element is nums \0. Nums or copy nums p. Don't want to do this. We don't want to make changes to the original. Copy nums dot sort. First thing, second position, second element is equal to copy nums second pointer, and we're going to go ahead and eliminate our problem here. Is we're just going to set that to 1. Okay. While this is where we can actually set up our first case. So while first element plus second element does not equal our target, continue. So we're going to do diff is equal to target minus first element which is nums. And we actually do need to do, we don't need to do this, but it's so much easier. Minus first element. Ugh, okay, you know what? We are going to actually do that. Shoop. Nums bracket first pointer. Nums bracket second pointer. And this is actually copy nums. If diff is greater than copy nums bracket first pointer, then we're going to do pointer right while second pointer is less than the length of nums, len of copy nums. Continue. So if copy nums bracket second pointer is equal to diff break if the second element, so copy underscore nums, second pointer is greater than the diff, we are going to break else second pointer equals second pointer plus 1. All right, and then here we're going to have our second here, L if L if else if diff is less than copy nums So the thing that we're running into, and I'm running out of stamina here, which is the reason why I'm getting a little bit more quiet, is because of the fact that there is another thing here where we need to decide what happens if the elements are the same. Do we just send it left or do we send it right? And I think I'm going to send it right due to the fact that I'm starting on the left side of the array. And that just makes sense because then I don't have to make all these edge cases of, well, if I'm the first one, then we're going to send it. Like, we'll just always send it right. If it is equal to, we just want to send it right. Okay. Diff is less than the copy of the thing. Let's move this up so I'm not. It's lesser. Break all these things. Organization. All right. So we're going to send the second pointer left. Fun. Okay, so sending the second pointer left. So second pointer is equal to the first pointer minus 1, while the second pointer is greater than 0. So while the second pointer is greater than 0, continue to loop. All right, so if copy underscore nums second pointer is ever equal to the difference, we will go ahead and break. The second element is less than the things. Oh, no. If copy underscore nums sp is less than the diff, we also want to break. Else, we want to move the left pointer left. Okay. We don't need to do this, so because of the fact that that is our case here, is when these two numbers do not equal the target, then we will break. All right, so get the indexes for the original elements, and I'm going to be real lazy here and just grab our check like so. And add that. Nums copy nums force printer if nums say copy nums bracket second pointer left index plus 1, and this one is just going to be copy nums second pointer And then we have our left and right indexes. All right, let's go ahead and run this and see if we have our tests. Sweet. Which means that it works exactly like we planned it. First try, hell yeah. Alrighty, let's go ahead and plug this in and see what we get. And then, once we're done with this, we'll go over the solution that that ByteByteGo has. We can do a comparison and contrast, and then we will call it for this. I did not realize how long it was going to take to do 3 different solutions for the same problem. So we'll do this a few more times, but I'm wondering if we'll just choose one or the other rather than just doing all 3 styles. I mean, it's good practice for sure. Goodness gracious, it's good practice. It's good practice, but I think that we're getting into this territory of unnecessarily long. So we will go ahead and see. Okay. Let's first run this, make sure that everything is working. Awesome. Hit and submit. List index is out of range. Oh. We need a catch case because I'm doing less than or equal to 1. How do I want to do this? Do I want to make a case check? Yeah, it's fine. We'll do the same thing down here because we're going to need to. Yeah. I think that's correct, but let's double check. Yeah. All right, so let's go ahead and it seems like I've miscalculated the indexes here. So let's go ahead and take this particular edge case here, and we're going to plug it in over here onto our test suites, and then we can go ahead and figure out where I'm getting the indexing wrong. Yep, there we go. Okay, failed. We're not getting the indexes quite correct. And honestly, I feel like I could probably do it in these things, but I'm just going to do really dirty things. If second pointer is greater than length of nums, copy nums, or second pointer is less than 0. Second pointer is gonna we're just gonna default it to left pointer plus 1. Just so we have that case of, oh, we've gone out of bounds. Let's do some recovery here. It may not be the most graceful way of doing it, but at least I'm pretty sure it will work. Oh, wait. Pretty sure it will work. Run the test, Evan. Duh. Okay, it doesn't work. Great. Fantastic. Is this because I don't have it indented on the right line? No, it's... this needs to be greater than or equal to. Probably actually just needs to be greater than or just equal to. But we'll go ahead and we're going to rerun this. Yeah. Did I hit an infinite loop statement? Wait, what? How did I hit the infinite loop statement? By the way, that's the definition of insanity, running it again to see if it changes. Which it doesn't. Why? Why am I hitting my infinite loop? Oh. No, it should just be that. Why am I... Oh. Because I need it to still go to 0. Duh. 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 Oh, son of a gun. God damn it. I'm just getting tired. I am getting tired. I need to finish the stream so I can take a break. Why? Why am I hitting an infinite loop here? All right, let us take a second, because I know how to solve this. I just am not doing it, which is to hold on a second. Let's take a look at the input case and then actually try to see what's happening. So it's going to become 2, 3, and 3. I'm actually just going to use the restroom here real quick. That will help move me around. So I'm going to pause stuff and I will be right back. And we are back. So, where were we? We were at the point of Evan is a dum-dum and has messed up his indexing. But why has Evan messed up his indexing? And this is because I am just using the incorrect thing. And that's because I've set my second pointer to second pointer. I think I'm just going to set it to 0, because then I'm not having to guess what to make where it is at. So excuse me? Oh. No. Oh, god damn it. What? How am I hitting the infinite use case here of pointing my second pointer at 0? That does not make any sense. Alrighty, so we're going to figure out why. We're going to actually start... Well, actually, you know what? I don't even know why I'm putting in print statements. I'm working in my IDE. I don't even need those. I can just debug this. All right, so we're going to run this on debug. We're going to send all of these. We're going to say no to all of those, and we're going to debug this. We're going to actually get through and figure out why on earth I am screwing this up. Okay, so we have second pointer is at 3. We have first pointer at 0. Oh my god. It is a miracle that I ran into this. So here's the problem. So dumb. I need to increment my first pointer. Gosh darn it. That's so dumb. And this is a good lesson. The lesson of the fact that if you're tired and if you're getting frustrated at something, you just stand up and take a break. That honestly will bring you so much more clarity than just trying to push through and find the answer. That is a wonderful example of just absolute insanity. I'm still sure I needed this, but man, that was dumb. All right, let's run this, make sure it's working. Yep, there we go. Things are working. Let's go ahead and uncomment this test data, make sure that everything else is still working. Cool. That's expected. It can come in any order. So let's go ahead and copy this in. So silly, Evan. So silly. Silly Billy. You're such a silly person. So silly. I don't think I had the, I did not add in my pseudocode the, increment the first pointer. I should have added that to the pseudocode. That's where I really went wrong there, is I should have incremented first thing, because I changed where my context was, which is where the problem really arose. Okay, so still worse than things. I would love to see what the okay, well, you know what? I'm pretty sure it's still O of n squared. O of n squared. Yep. Yep. That's what I thought. Mm-hmm. Yep. Because it would go all the way to the thing and then go all the way back. No, it's still because there, and we're going each direction. Yep. Okay. I am seeing this, combining all the parts of O of n at log n plus O of n squared plus O of n. The time worst case complexity, which is the worst of them all, is that O of n squared. So it's not any better than the unidirectional search, which is I had an intuition about that, but you've listened to me through that, but it's good to know. So what we've learned is that our best option for this was in fact using the inward traversal, which is interesting because I originally thought that this one would be. I don't think I originally thought that. I think that this one wasn't the thing that I had thought about. So let's take a look at the way that Pipe Like Go has put it. All right, pair sum sorted. Given an array of integers sorted in ascending order and a target value, return the indexes of any pair of numbers in the array and that sum to the target. The order of the indexes does not result, and if no pair return an empty array. So just off the bat, there is a difference, right? They're saying that there is a potential of there being 0. And additionally, they're doing the sorting for us. Whereas in leak code, they don't do the extra the intra things. So, intuition. The brute force solution to this problem involves checking all possible pairs. This is done using 2 nested loops, an outer loop that traverses the array for the first element and pair, and an inner loop that traverses the rest of the array to assign the second loop. Below the code snippet for this approach. Of O of n squared, that is correct. Thanks. So this is where we're going to think. So a 2-pointer approach is worth considering here because a sorted array allows us to move pointers in a logical way. Let's see how this works in the example below. The target 7. A good place to start is by looking at the smallest and largest values. The first and last elements, respectively, the sum of these 2 values is 1. Since 1 is less than the target, we need to move one of our pointers to find the new pair in with a larger sum. Moving the left pointer will always point to the value less than or equal to things. So literally the exact same that we did. Yep. Until we've... Thanks. And then for this, we're also... Okay, so they did it even slightly different. I did the difference of them, and they're just using the sum of those. So I added a bit more complexity to the problem. And the reason why their time complexity is O of n instead of O n log of n is because they're doing the sorting for themselves. Since they do the sort themselves as part of the input, they are able to not, they're not suffering from the fact that we have to, the fact that we had to bring order to the array in and of itself. All right, so we got similar test cases, except for the fact that they have empty ones, so that's fine. So the interview tip for this is consider all information prior. When an interviewer poses a problem, they sometimes provide only the minimum amount of information required for you to solve it. Consequently, it is crucial to thoroughly evaluate all of the information to determine which details are essential for solving the problem efficiently. In this problem, the key to arriving at an optimal solution is recognizing that the input is sorted. I think that some of the other things that are important to realize beyond just the fact that the input is sorted is the constraints. What was the original one looking like? Because of the fact that if we looked at the way that LeetCode did it, in the fact that they gave us an array that does not or is not sorted, you have to maintain that idea of where was the originals at. So it's not only just asking the questions or recognizing that the input, it's realizing the implications of what those constraints and changes into your inputs and your outputs are. But yes, there is pair sums. We used all three methods. We realized that two of the three methods are significantly less performant than the other two, and we realized that the other one was the more performant one. So, with that, we have completed pair sum sorted. 2 hours to solve an easy problem. Good Lord. And we realized that I've added a little bit more complexity. That complexity being using the difference instead of just looking at the two different sums. I think that's something for me to think about is, am I adding more complexity to the situation where it's not needed? And additionally, I think that some of the other learning lessons here is that, hey, if you're getting frustrated, if you're tired, take a walk, stand up, do something different, come back to it. You don't necessarily need to solve it right then and there. It might need taking a little bit of a break, might actually clear up and actually cause that solution that you're looking for. And then making sure that your pseudocode actually takes into all accounts. As you can see, I got a little lazy on that third one. Forgot to add the indexes, and look how much time it added. Is impeccable and crucial to make sure that you are taking into account your pseudocode and working through each of those problems as you're going through it. And so we'll definitely take a look at this again. We're gonna not two pair sum. We'll do another one. Next time, though, we're only going to probably just do one of the strategies instead of doing all three, especially the one that makes the most sense. Okay, and with that is pair programming, or not pair programming, that is the algorithms bit for pair sums as a part of using two pointers with the various strategies.